Okay, so for each of these cases, and there are going to be 4 of them, describe the series of transformations required to turn root x into the thing they gave us, sketch it, and then work out its domain and range, and then get out a calculator and see how you did. So, they start us off with y minus 4 equals root x plus 2, and I find these are much easier to deal with if they're in the form y equals. So the very first thing I'm going to do is boot that 4 over to the right. We get y equals root x plus 2 plus 4. So with the transformations in this position, we can see that we have a horizontal translation here and a vertical translation there. How big are they? Well, sorry, not how big are they. Which direction are they in? Well, horizontals sadly are backwards. When this says x plus 2, that means 2 units to the left. And verticals make sense, at least to me. Plus means up and minus means down. So plus 4 means 4 units upward. So the series of transformations would be a horizontal translation 2 units left, vertical translation 4 units up. Rough sketch, easy enough. Starting from here, we would have to go 1, 2 units to the right, 1, 2, 3, 4 units up. There's our starting point. And nothing has changed about the shape of the curve, so I'm trying to mimic that original arc as best I can. Domain and range? Well, before we get to that, what are the domain and range for your basic radical, just for root x? You can see it doesn't exist for negative x values. It kicks in at 0, and it exists for everything above that. So for your generic root, we have x can be any real number provided that number is bigger than or equal to 0. And in the y direction, coincidentally, we get the same thing. We get no negatives, no negatives, no negatives. At 0, it starts existing, and it exists for every number above that. So there's the domain and range for our original root. Now, if we shift that 2 to the left and 4 up, this curve in the x direction starts existing at negative 2. So our new improved domain would be x can be any real number that's greater than or equal to 2. And for our range, it doesn't exist for the negatives, or 0, or 1, or 2, or 3. It's 4 before we start getting curve. So y can be any real number as long as it's greater than or at least equal to 4. Okay, let's see if we can accomplish that again. 2y equals, again they give us this number in a place I'm not too happy about. Let's get rid of that. We'll multiply the left side by 1/2, the right side by 1/2. So our curve is y equals 1/2 root negative x. So what effects do those two values have, this 1/2 and this negative sign? The 1/2 is a vertical stretch. So what we get here is a vertical compression by a factor of 1/2. This is horizontal because it's right on the x. It's inside the radical. And it's negative, which makes it a reflection. So this is a reflection, and there's several ways to say this. You can say it's reflected left to right. You can say it's a horizontal reflection, or you can say it's a reflection across the y-axis. Now, as with the previous example, we have one vertical transformation and one horizontal transformation, which have no effect on each other. So it doesn't matter in what order we do these. We won't have that luxury forever, but we have it right now. So for this curve, I'll do the reflection first. Here's your original half parabola. If you reflect it across the y-axis, the reflection ought to look something like this. It should look like a mirror image across the y-axis. Then for a vertical compression, we draw that same shape again, only now it's only 1/2 as high. So where the original curve was this high, ours should be about there. Where the original curve was this high, ours should be half that height. There's the original curve and about half that height, original curve and about half that height. You can plot as many points like that as you wish to make sure you're comfortable with the shape that you need to come up with. And so that red line would be our transformation image after reflection and a compression. For domain and range, well, this one actually exists for all the negative values of x and for 0, and then it cuts out for the positive values. So for this one we get x can be any real number as long as it's less than or equal to 0. Normally we're saying it's greater than, it has to be on the high side, but not today. And the vertical didn't do anything to our range really. This curve doesn't climb as fast, but it's still going to become infinitely high if you go out far enough. And so nothing happens to our range. We still get y can be any real number that's higher than or equal to 0. Next one, they persist in giving us those numbers on the wrong side of the equals, and I'm going to persist in putting them where I think they should go. If you're comfortable reading that 5 on the left-hand side and saying, that's 5 units down, then terrific, but I think it's easier to do this way, and I've always done it like this. You're never going to regret changing your equations to this form. So here, our two transformations are, we have a vertical reflection, also known as a top-to-bottom reflection. Sorry, didn't mean to say that. Top to bottom is what I was going for. And you can also say that's a reflection across the x-axis. And this is a vertical translation 5 units down. Now, both of these are vertical, and so it matters what order we do them in. If we do it in the wrong order, we'll end up transforming our transformations in a way that will mess up the graph. So what happens first? Sometimes they tell you you should stretch and then reflect and then move or translate. Sometimes they tell you alphabetical order, RST, reflect and then stretch and then translate. Either one of these is actually okay. The important thing, which both of these do, is your movements or your translations have to happen at the end. You have to do your stretches and reflections first, and then it's only then is it safe to apply your translations. So, in this case, the 5 down is going to wait. The first thing I'm going to do is reflect this from top to bottom. Here's my original curve. The reflection image will look like that. And now that I have that, I move it 1, 2, 3, 4, 5 units down. And there is my reflected and translated curve. For its domain, well, it doesn't exist for the negatives. It starts at 0 and then is fine for everything above that. So we get no change in our domain, actually. X can be a real number as long as it's bigger than or equal to 0. And for the range, there's nothing in the positives. Nothing at -1 or -2 or -3 or -4. This kicks in at -5 and goes down from there. So we're going to get y can be any real number as long as y is lower than or at least equal to -5. And last one. For once they actually give it to us solved for y. And, they gave it to us solved for y, but they try to sneak something else past us. Take a look, please, at the top left, page 442. Can you tell me what's wrong with this expression the way they've given it to us? There's a trap in here. See where it says transforming y equals root x to y minus k equals a root b x minus h. You see how that b is factored out and there's brackets? This too should be factored out, and it is not. They were trying to catch us with that. If you want to do these correctly, here's how this thing has to look. Root, factor out the 2. 2x divided by 2 is plain old x. -1 divided by 2 is -1/2. Now we can look at this and say, okay, we've got a vertical stretch or vertical expansion by a factor of 3. We have horizontal, what? It's a compression. Horizontals are backwards again. It's a horizontal compression by a factor of 1/2. And we have a horizontal translation, half a unit to the right. The people who didn't catch this are writing translation 1 unit right now, and they're going to get thumped for it. You have to factor this 2 out, or you won't get a correct value for the translation, and it's going to mess up your graph. So, what order do we do these? We know the translations have to come last, so this half to the right is the very last thing I'm going to do. First, I'm going to expand this by a factor of 3. So, every point on the graph should become 3 times higher than it used to. And let's say this point should be 3 times higher than it used to, so we get a pretty dramatic hook from that. Now we do horizontal compression, and it gets even worse, actually. For the horizontal compression, we have to take these points from our current curve and cut their x-coordinates in half. So now they get even closer to the y-axis. All these distances from the y-axis get scaled down to half of what they used to be. From there to there is like there. So now we get a curve that is even more steep. It turns out the vertical stretch and horizontal compression are doing pretty much the same thing to this curve. They're making it go more and more vertical. And now last thing we do is we take that curve and we translate it half a unit to the right, which is going to be tricky to draw, but it should still have a very sharp curvature to it, only it's slid to the right a little bit. What does that give us for domain and range? Well, that curve doesn't exist in the negatives. It doesn't exist at 1 either. It actually kicks in right here at 1/2. So we're going to get x can be any real number that is greater than or equal to 1/2. And our range, actually none of these things affected the range. The range is still non-existent in the negatives, and then it kicks in at 0 and covers every number above that. So y can be any real number as long as it's greater than or equal to 0.